Hello, chemistry students. Welcome back. We're at Big Idea 2 and just kind of going through some general things that you probably should already know. But this is solution problems. And so I'm not going to work out too many problems in this way because if you don't understand how to do any of these, if I just simply show you the formulas, you should probably not be in AP chemistry. So sorry, but that's the reality of it. So as far as solving problems for solutions goes, okay? First of all, there's simple molarity. Now, many times in solutions, we have to know what the concentration is. So right here, we have concentration expression called molarity. And so molarity is going to show us basically how many little particles are dissolved in the solution. This, of course, comes into play in all sorts of calculations. So molarity, it's a big M, and moles of solute, and then over a liter of solution. So it's always moles over 1 liter. All right, and so you'll be doing lots of those. Another one that comes up occasionally is molality. I'll go ahead and leave that one up there. Molality also expresses concentration of solutions. Molality is a little m, which is kind of italicized, but I can't do italics when I draw because it's hard. And so molality is where you actually have moles of solute over kilograms of solvent. Now, typically this is used in all of the problems where you're searching for like boiling point elevation or freezing point depression or vapor pressure. So all those colligative properties often uses molality. But the only difference between molarity and molality is this is over liter, this is over kilogram. And then finally we have mole fraction. So commonly we want to know mole fraction, or what is the fraction of the moles to the whole. So it's pretty simple. So whatever substance, we could say S as substance S, whatever the moles of the substance is divided by the total moles in the solution is going to be the mole fraction. So these three formulas right here are going to get you through a good bulk of your solution problems. And so, know them, memorize them, learn them, just keep them tucked away always. I'm going to go ahead and bring up a couple of points real quick. What about solving solution problems? Some of the keys to remember in solving solution problems is like dissolves like. So that means what? It means a couple of things. It means that polar is going to go with polar. Hang on, let me get this back on here. All right, polar goes with polar, right? And nonpolar with nonpolar, okay? So like dissolves like. So anything that is a polar substance, like a salt, like an ionic solute, is going to dissolve in a polar solvent. So water is a great polar solvent. It's going to dissolve all of your ionic polar solvents and all of your polar covalent solutes. So and then if you have nonpolar, some organic compound which is nonpolar, some covalently bonded thing which is nonpolar, you're going to want to dissolve it in something nonpolar like diethyl ether. Ethanol works even though ethanol is sort of polar. That's kind of a neat one. So ethanol comes into play there because it has attributes of both polarity and nonpolarity. So it can be used that way. One thing that comes up, and I've got this written out here so I don't forget, one thing that comes up when you're solving anything that has solutions in it is you need to know what the thing is going to break up into. For example, if I have a solution and I'm trying to solve for the effects of sugar in the solution. Well, sugar is a polar. It's a polar covalent situation. So this is going to stay together, right, when it goes in solution. So my Van't Hoff factor here is going to equal 1 because it's not going to break up into anything. But something like calcium chloride is going to break up into 3. So each one of these things is going to break up into a calcium, right? And it's going to break up into 2 chlorines. So the Van't Hoff factor will come into play anytime you have this little I in the equation. So all the colligative properties, which is talking about how the solute affects, boiling point or freezing point or vapor pressure. All of these things are going to have a pull, right, on the water molecules around them, for example, or whatever polar solvent they're in. And so this one's going to have an effect multiplied by 3 because it breaks up into 3 separate ions, which are pulling on water molecules. But sugar doesn't. Sugar breaks up, or doesn't break up at all. So, and then you have in between, like your acids always have a Van't Hoff factor of 2 usually, right? So like NO3, it's going to break up into H and the NO3, so that's going to be 2 separate ions in there that's going to cause a Van't Hoff factor of 2. Okay, so keep those in mind. No Van't Hoff factor, it's a little I, and just realize that then you're thinking about when something dissociates or dissolves in either the polar or the non-polar, what's it going to break up into? So most of the time, we're only talking about polar substances, and ionic bonds are the ones that are going to go up over 1. The polar covalents are all going to stay together. Okay, so hopefully that helps. In the next video, we're going to do some example problems on Big Idea 2 that should help to kind of put all this stuff together in some ideas and just examples.